Hi, welcome back. So we're going to finish this off now, do the rest of the questions. The first one is that one. So read through, and when you're ready, press play. Okay, so we've got that keyword mean literally all over the place. And we are having to find out if the mean weight of all the blocks is less than 5. So we need to find out the total of all the blocks so that we can actually work out the mean of them all. So our first step is to say these questions are a different context, but pretty much have the same steps regardless. So there is a total that when it's divided by 4 gives a mean of 6. 6 times 4 is 24. So that is the total of the red blocks. I'm going to repeat that here. And then we've only got one green block, so it has a weight of 4. Okay, so that doesn't change anything. Add them all up and you've got 24 plus 40 plus that 4 as well. That's going to give you 68. 68 divided by how many are there? Altogether, there are 10 blocks, which is going to give me 6.8. So she's very wrong. It's not going to be less than 5 at all. And we could kind of sense that with the numbers that we were given, but we have to make sure that we prove that. All right. Okay, next question. There you go. Hit pause, press play when you are ready. All right, so here we go. We have a shop with the normal price of a coat at £85. It has a sale. In week 1, it's reduced by 20%. In week 2, it's reduced by a further £12. So there's 2 things happening. We need to do it one at a time. So that first line, the price is reduced by 20%. We've got a decrease. We've got a percentage. It's a 2-tick question. So it's original times multiplier equals result. The original is £85. The multiplier is 100 take, I'm going to say 80, take 20, which is 80. Okay. And that's 80%. 0.8 is the decimal version. I put that into my calculator and I get 68. So it's reduced from 85 to £68. But in the second week, a further 12 is taken off. So 68 take away 12 is 56. He has 55. So does he have enough? No, he is literally £1 short. He'd be gutted. So £56 is what that now costs. If you got that right, fabulous. Remember, with these types of questions, read them through and then just take your time, one bit at a time as you go. All right, we got another question. So have a little read of that. I'll just get rid of that so we can not be put off by anything. And press pause when you're ready. Okay, so the alarms are going to go off at 8:45, and then Tilly's is going to go again every 9 minutes, and Aaron's snoozing for 12 before he hits snooze a second time, assuming they're in bed waking up in the morning. So what time will they both sound again together? Now, you can say it's 8:45. I'm going to add, because I've got 9 coming out of my mouth. It's 8:45, and then you could add 9 to that. And if you did that, it would be 8:54. And you could keep going. But I think adding on in time is a lot harder than just adding on. So we're going to scrap that as a plan. And we're going to do every 9 minutes. So every 9 minutes would be 9, 18, 27, 36, and so on. Every 12 would be 12, 24, 36, and so on. But I can see that I've already listed enough to show that they are both going to go off again in 36 minutes. So what I'm going to do is add 36 to the 8:45. So it's 8:45. If I add 15 minutes, that will take me to 9. So I had 36, I've used 15, I've got 21 left. And when I add that 21 minutes, I get to 9:21. So 9:21, remember your AM, we're not using 24-hour clock here. So we want that AM shown as well. Now be really careful with time questions, little word of warning. I see it happening all the time where students put time into columns and they add like it's column addition, and it doesn't work. So the examiner knows that students do that. So they write a question where it could go wrong, very wrong, if a student did that. So do be really, really careful. Think of it as adding on in minutes, knowing that when you get to 60, you go over that hour. So don't use a calculator. Really, really important. All right, question 18. Have a read through and then press play when you're ready. Okay, so this is a percentage question. I did look really hard for the estimate, but it wasn't there. So it's not an estimate question. It is a percent question. So I'm reading that we've got a garden that is 120 meters by 80 meters. 60% is going to grow vegetables and the rest of the garden is going to be grass. And we have to work out the area that is grass. Now you could do 60% and then take that away, or you could just do 40%. If 60% of the garden is vegetables, then 40% is grass. If I want to find 40% of the garden, I'm going to need that area before I can carry on. So the garden is 120 times by 80. Area is base times height. Then 120 times 80 is 96 with 2 zeros. So I'm finding 40% of 9,600. And that is 3840. So that is the numerical number, the area of the garden. It's 40%. Remember your units, meters squared. As I say, you could have found 60% and then taken it away from there. Nothing wrong with that at all. If your end result is this and you did it a slightly different way, still going to be getting all those marks. That's one of the things with maths. There's always more than one way. And we do the way we see, don't we? All right, there's question 19. Think about that. Press play when you're ready. Okay, so Rosie's weight in kilograms is 4x plus 8. So basically, it's a number I don't know. 4x plus 8. A piece of algebra like that is expressing a number I don't know. So she's got a weight, I just don't know it. And Millie's the same. So this is an example of, again, where they try and take a topic that you know and put it in a context that's unfamiliar to see how confident you are with what you know. We've got to write down an expression. So we're going to be writing down something that looks like this. Okay, it says in terms of x, that means that x will be in our answer. So we're going to have a piece of algebra with an x in it, and it's going to express the mean of their weights. Mean doesn't change just because they've not really given us numbers, they've given us algebra, but it doesn't change. It's add them all up and divide by how many are there. So when I add them all up, I'm going to add Rosie's weight, 4x plus 8, and I'm going to add Millie's weight, 6x plus 14, to get a total of 10x plus 22. Divide by how many are there? Well, how many people's weight have we just worked on? Just 2 people. So I'm going to divide by 2. And then I'll say, I'll do each one in turn. How many 2s can I get into 10? I can get 5. So I've got 5x. How many 2s can I get into 22? 11. And that is my final simplified perfect expression. So it's an expression and it's in terms of x because I've got that x there. And that is the mean expressed as a number I don't know. If you did that, then really, really well done, because it takes quite a lot of confidence to see something really, really different, but then trust in what you know and just use that knowledge the best you can. So if you did get that right, honestly, really great. All right, question 20. There you go. Press play when you're ready. Okay, so we've got that interval for the median, which I always think is a tricky one, especially for the number of marks that it gets. I'd certainly recommend if you were struggling to remember everything, you get that estimated mean nailed first. Okay, there's more steps, which means there's more marks and it's more common. So if you were struggling, that would be my advice. Get the mean absolutely 100% secure before you worry about the median. And if mean secure, then yeah, really start getting that focus and that attention on the median. So to find the median, we take how many are there. So we add up the frequency. When we add up the frequency, we get 40. Okay, so you can just work on the 40. The correct way is to add 1 and divide by 2, which would give us 20.5. And in this case, it's really worthwhile. Like I say, most of the time it makes no difference whatsoever. So if that adding 1 with like an extra detail that you just weren't holding on to, as long as you remembered everything else, you'd probably get it right anyway. But this one's quite specific because we then look at our frequencies, don't we? So we say that the first 8 people go to 10. Okay, so 8 people are going to 10. Add on another 3, and then we can say the first 11 people go to 20. Add on another 9, and you can say 20 people go up to 30. Well, we got 20.5, so we do actually go into that one there. And if we didn't add the 1, we would have gone in the one in front. So when it's literally on the edge like that, that +1 becomes quite critical, but it is also quite rare to happen. Really important that you're aware of these things though. So the median is going to be 30, 40. And then I'm going to clean all this off because the next question is asking me to estimate the mean. So I've got mean, I've got table, I've got mad every time. So my midpoint is 5, which I will times through, and I will do that all the way along. So 25, 35, 45, they will all get multiplied. So we've got our 40, our 45, 25 nines, 225, 35 times 11 is 385, and then you've got 405. We add this up and we get a total. So when we add that, I'm going to do over here where there's a bit more space, we get 1,100. We've already added this, we know it's 40, so we'll divide through by 40 and we get 27.5. So hopefully that went well. Okay, question 20. There you go. Hit pause and press play when you're ready. Don't know if I numbered the question 20 twice or not. I've got a funny feeling, but I'm not going to go back. So in a sale, the normal price of a pair of socks is reduced by 20% and the sale price is $4.20. So we know this story, it's got a percentage, it's a decrease. So I've got 100%, take the 30% to get me 70%. My multiplier will be 0.7. I've got original times multiplier equals results. I don't know the original. I just know that when it got multiplied by 0.7, it decreased to 4.2 or 4.20. To finish this off, I want to get the original on its own. So I'm going to divide through by 0.7. And that gives me the answer of £6. So the original price of the socks was £6. All right, next question. Press play when you are ready. Okay, so we've got a table with some probabilities. Green has not been included. We need to work that one out. So this is testing whether we know probabilities add to 1. So what the examiner really wants is to see that you're working with that number 1. So we're going to add what we know. Okay, which gives us 0.8. And then 1 minus 0.8 means that green is 0.2. And you'll likely have a dotted line that you would actually write that on, okay? Really important to show that working out if you want to get all those method marks. Now, if a colour was chosen at random 50 times, work out an estimate for the number of times the colour yellow would be chosen. So I'm really only interested in the probability of yellow and the fact that it is 50 times. So it's 0.24 times through by 50, and the answer for that is 12. So hopefully that went well. And there is your next question. Hit pause and press play when you're ready. Okay. So find the highest common factor of 72 and 90. Now, I could look at all the factors. I could do factor bugs, okay? 72, 1 and 72, okay? 2, is it in the 3s? Is it in the 4s? Is it in the 5? It could take a long time. And actually, it's probably far easier to use the product of prime factor method on this. So I'm not saying that that isn't a good approach. It would work, but you've got to have made sure that you found them all so that you know you haven't missed any off. Whereas 72 would actually break down into prime factors pretty quickly, to be fair. That would be 4. And then our 9 is 3 times 3. So 72 would go in that circle. 90 would go in this one. We've got 9 and 10, 3 and 3, 2 and 5. And then what can we match? Well, we've got those 2 3s, so they can go straight in. Okay. We've got a 2, they can go straight in. I don't actually have to finish that diagram. I'm only interested in highest common factor, which is this crossing section here. So that's all I'll do. 3 times 3 times 2. Okay, and that is equal to 18. So having that skill just means I can find these things really, really easily. The next question was write down a multiple of 6 between 70 or 80. Okay, so we're really just thinking about our times tables here. 72 is in the 6 times table, and then obviously I could add another 6 to that. 78 is as well. So either of those 2 answers would have been correct for that question. All right, there's your next one. Read it through carefully and press play when you're ready. Okay, so lots of words, a big story. We need to try and get the context straight in our head, and we need to make sure we have spotted this so we don't create an awful lot of work. So the first mark's going to come from the rounding. I could almost round without reading anything now and be getting marks, but I am going to read the story. So we're in a cycle race across Australia that is very, 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 very long. He knows his average speed for his previous race was 18.12 miles per hour. And for the next race, he will cycle for 5 hours every day. And we're trying to get an idea of how long it's going to take him. So let's round. We've got 4,000 here, and we're going to round to 20. We don't want to round to 18. 18 is not an easy number for us to work with, even though it's tempting to round to that. We're talking about speed, and we've got distance. We want to know how many days, which is times. There's our distance. So we've got speed, distance, time in this question as well. Dad's on top. And then I think about what I've got. I have got distance. I've got 4,000. And I've got his speed, which is 20. So when I cancel this through, and then 2 into 400 is 200, that's telling me it's going to take 200 watt. And this is where we need to be able to make sure we know what we're kind of working on. Our speed was miles per hour. Okay, miles per hour tells me that 200, the time, must be hours. So now I got to be thinking about the fact that he's only going to be traveling for 5 hours every day. So I'm going to be dividing my 200 by 5 to see how many days this is actually going to take. So 200 divided by 5, carry the 2, 5s into 20 go 4, 5s into 0 don't go. We have got 40 days. He is going to be cycling this race for 5 hours every day for 40 days. And that is our estimate. Well done if you got that one right. There's your next question. Okay, so we have prime number 31. There isn't another one there. So 31 is the answer. A cube number, a number multiplied by itself, 3 times 3 times 3. 3 times 3 is 9, times 3 is 27, so 27. A factor of 12 could be 4 or 6. So either of those two would be correct. And then two numbers with a difference of 5 that have a product of 36. So my two numbers must take away to make 5 and multiply to make 36. So you may have to do a little bit of trial and error there, but 9 and 4 are the two numbers. 9 times 4 is 36. 9 take 4 is 5. So 9 and 4 would be the correct answer there. Okay, next question. Press play when you're ready. So we've got an insect population that's decreasing by 0.8%. So we know that it's a 2-tick question already. If the population was 22,000 on August the 1st, what would it be a week later? So this population is decreasing every day. What would it be a week later? This has a period of time in the question. So we've got time on our original times multiplier. Okay, so the multiplier is the first job. we've got 100%, and we're going to take away 0.8%. Okay. So when we take that away, we end up with 99.2%, which will obviously move 2 places. We're going to end up with the decimal 0.992. Our original population is 22,000. Times that to the multiplier, period of time. So it's reducing every day, and we want to know what it will be a week later. So that's 7 days later. That means that our power is going to be 7. You pop that into your calculator and you get 21542.137, on and on and on it goes. So the population will be 21542. We would round to the nearest whole because it's an insect population. So you can't have just a tiny part of an insect. So that's the answer to that one. All right, there's your next question. Hit pause and press play when you're ready. Okay, so this one's a little trickier. We've got 2 blanks and it's not evenly spread across them because the probability that the blue counter is twice that of the green counter. So I think the first thing to do is to just find out what they're supposed to actually be. So we've got 0.4 plus 0.45, which is going to give us 0.85. Take that away from the 1, which is the value now, which has got to spread in a way that means 2 lots of it are in there and 1 lot of it in there. All right, because it is a 2-to-1 split, it means that we would be dividing by 3. So I'm going to take my 0.15, divide it by 3, and it will give me 0.05. So the blue counter is twice that of the green. So the blue counter is going to be 0.1. And then this is going to be 0.05. Together they make the 0.15 that it needs to make. And one is twice bigger than the other. So hopefully that one was okay. Definitely a little bit harder. So a counter is taken, it's color noted and then put back. It's repeated 50 times and you needed to work out an estimate for the red. So I'm now only interested in red. That probability is 0.4. I'm going to times that through by 50 and it will give me an answer of 20. Okay. All right, next question. There you go. Darcy's in the kitchen. So hit pause and play when you're ready. Okay, so we are literally going line by line on this. So she's got a total of 420. That total needs to be shared out amongst OT, Lemon Crunch and chocolate using what we've been given. So 2/7 of the 420 are OT. So you're literally 2/7 of 420. Pop that in your calculator. If it was a non-calculator, it's actually quite straightforward as well. Dividing by the bottom, timesing by the top. 7s into 42 go 6. So that would give you 60. And then doubling it would get you 120. So fairly straightforward. And the numbers, if it is on a non-calculator, if your exam has a non-calculator paper in it, then they are going to choose numbers that are usable, that work and aren't going to, send you in a spin. Because that's not really the point. So 35%, remember, is 35 out of 100. And we're timesing that through by 420. That gets us 147 lemon biscuits. And then the rest. Now, remember, the rest are the OT and lemon biscuits taken away. So we'll do that, 420, take away 120 and 147. That is my rest. which is 153. So I've got crunch and chocolate, 4 to 5. Okay. The ratio has a total of 9. I have got a total of 153 biscuits that are actually left. So you work out by dividing. 153 divided by 9 tells you that you've got to multiply by 17. So you times this by 17. The question only wants to know about the chocolate biscuits. So I'm going to do 17 times 5 to finish off. And we've got 85 chocolate biscuits. So all of these steps are basics. They are basics. You know how to do this. They're just putting it in a question where there's a lot of information to digest. And you've got to really think step by step how you go. All right. All right. Question 28. Hit pause and press play when you're ready. Okay, so a laptop is reduced by 15% and sold for 578, and we want the original. So this is a decrease by 15%. So 100 minus 15 is 85. So 0.85 is my multiplier. So don't know the original. I just know that when it got multiplied by 0.85, it got reduced to 578. If I want to know what the original is, I need to get it on its own. So we're going to bring that times. It'll land as a divide. And then I get the answer of 680 coming out. So the original was 680. Now, a lot of people can find this a little tricky, but if you think about this, all right, if you don't deviate from your knowledge of the multiplier, if you were to stick the 578 here by accident, you just weren't sure, so you put it there, and when you multiplied through, it didn't work because it wasn't a bigger number, you just know you put it in the wrong place. That's what could then tell you, oh, I should have put it here. What happens is people start messing around with this section when it doesn't do what it wants it to do, or they put a divide here. So confidence with your multiplier means that you will be happy to just leave that alone. And if you're not happy with your answer, you can try the other number in a different position. But hopefully our confidence with this is high enough to not worry about that. I'm just kind of giving some hints and ideas if there is anyone struggling a little bit. All right. Okay, so this is the last question, literally the last question of the course. So for the last time, hit pause and press play when you are ready. Okay, so what type of correlation does the scatter graph show? That is positive. They have an upward trend. So we're definitely looking at a positive correlation. Susan scored 12 on paper 1, but was absent for paper 2. So we do the estimate. This is where our line of best fit comes in. So again, trying to hold things as tight as you can. So they're not a bad distance from each other. They're not a bad distance at all from each other. These are hugging quite close. This one's a bit closer than that one, but to move this had a big impact on that. So I went with that in the end. And then you read up, hit the line, come across, and you've got your answer of 18. So if you got that right, really, really well done. So that's it. That's the end of this set of work. I really, really hope that you have felt like you've made a lot of progress. I think it's really, really good to reflect on where you were at the beginning and where you are now. That's a real measure of how much is working with what you're seeing and what you're doing with your practice. 100% is a very, very difficult goal. Not even the exam is looking for 100%, are they? So allow the errors, allow them to be something that you learn from so that you can improve, but don't allow them to bring you down. Don't allow them to be like, oh, I'm never going to get it right. You know, if you're making progress, if you are more confident on a topic than you were before, then you are heading in the right direction. You should be really happy with that. So just like a massive congratulations. Thank you for studying with us. Genuinely, we really hope that our courses are useful and helpful. And if there's anything we can do ever, just give us a shout. So if you're going to do another course with us, brilliant. I look forward to working with you again. If you're all done, you've got those exams looming, then may I wish you the very, very best. All right. Thanks again for doing your Maths with Target Maths.